This video will be a brief introduction to calculus with a look at tangent lines and approximating curves. So the first thing we'll look at is what a secant line is. A secant line is a line that passes through 2 points of a curve. So for example, if I have a line that looks something like this, then a secant line could pass through these 2 points of the curve, and it looks something like this. We could draw more secant lines by choosing more places on the curve. So if I chose these 2 points, then I would end up with a secant line like this. Or if I chose 2 points here and here, I would end up with a secant line like this. So a tangent line is similar, except that it only passes through at 1 point. So imagine that we have a curve. I'll draw something similar. Then a tangent line at this pink point would look like this. So it just barely touches at this 1 point, and then they diverge from there on. So if I wanted to draw some more tangent lines, a tangent line at this point would look something like this, and a tangent line at this point would seem pretty vertical. So now let's think about how to go from a secant line to a tangent line. So let's imagine that we have, a simple graph, y equals x squared, and I want to find a tangent line at this point in white. So I can start out by just drawing secant lines with 2 points surrounding the point that I'm interested in. So I could do something like this with my 2 points in pink, and I could draw a secant line. Okay. But then what if I move my 2 pink points even closer to the white point? Then let's say I have something like this. Then when I draw the line, it approximates even closer the tangent line. And so, if I draw an actual picture of my tangent line, we can see that if you bring the pink points extremely close to the white point, then it becomes very, very similar to a tangent line. So if we have a graph, let's say that this is f of x, and we have a point. We'll call this point x1, y1. Then if we draw a tangent line through this point x1, y1, then the slope of the tangent line is equal to the slope of f of x at x1, y1. But since f of x is not a line, it might be confusing to think about the concept of a slope of a curve. So instead, we'll clarify this by calling it the instantaneous slope. Or the slope at one instance in time. How do we find the instantaneous slope? Well, we already know how to find the slope between 2 points on a curve. So for example, if we want to find the instantaneous slope at the point 1, 1, what we can do is take 2 points 0, 0 and 2, 4, and we can draw a secant line between them. So then you know that the slope of this secant line is equal to 4 minus 0 over 2 minus 0, or 2. So this can give us a kind of rough approximation of the slope at 1, 1. But we can do better than this. What if we choose a point that's 0.5, 0.25, and how about 0.6 and 0.36? Now let's find the slope of this secant line. That would be 0.36 minus 0.25 over 0.6 minus 0.5, which gives us 1.1. And so since these points are much closer to the actual tangent line, then we know that it gives us a very nice approximation of the slope. What we can do then is bring these points extremely close to 1, 1. So for example, we could try something like plugging in 0.99 and 1.001 for our two x's, finding the y's for that, and then taking the slope. And that should give us a very good approximation of the slope at 1, 1. If we have a curve, sometimes it's easier to analyze lines instead of curves. So let's say we have some sort of strange squiggly curve that looks like this. What we can do is we can approximate it using lines by dividing the curve into small pieces. So if we just take points at every so interval along our curve, we can draw lines connecting these points. Then you see that we have a picture that looks pretty similar to what our curve actually looks like. The more lines you draw, the closer it will approximate the curve. And if you draw infinitely many lines, then it will be exactly the curve itself.